Climate-smart agricultural practices are gaining importance as a way to address the global climate crisis and achieve net zero carbon emissions. Researchers at the University of Illinois at Urbana-Champaign are advancing our understanding of ways in which we can promote adoption of climate-smart agricultural practices and illustrate the benefits to farmers from increasing soil health, regenerating the soil, and increasing crop yields. We need to study ways in which we can provide incentives to farmers to adopt these practices, as well as understand the barriers that they currently face.
As Environmental Defense Fund thinks about climate-smart agriculture, it involves two main goals. One is to mitigate climate pollutants from agriculture. Then at the same time, agriculture also needs to build its resilience to the impacts of climate change that are already occurring. All of those effects obviously impact farmers and the crops and livestock that they grow. And in order to maintain food production, we also need to build resilience to those ongoing impacts.
As we watch extreme weather events, from flooding to drought to wildfires, we worry about what that means for food production in our food system and how our policies can shape around it. Congress is currently in the middle of reauthorizing a farm bill, which is our federal policy for food, agricultural, and natural resources. And arguably one of the most important, one of the top topics for that farm bill debate in Congress right now is around climate change, agriculture, and the food system. And we here at the University of Illinois are looking to apply some of the phenomenal research into that policy space. So one of the challenges we're facing is how do we adapt and how do we invest in farming and farmers to help resolve this, help build resiliency. And a great example of some innovation in that space has been the Climate Smart Commodities Partnership Program that the USDA announced about a year or so ago, in which grants have gone out and funding is going out to help boost research applied to the way we produce commodities in a more climate smart or more climate friendly set of practices.
The University of Illinois is home to world-leading climate science, particularly when it comes to how agriculture influences and can be influenced by the climate. What we've learned over the last 50 to 100 years here is how to grow the calories that help the world survive in a range of climate conditions. But where we're going next is how we manage this land and those calories to help the world thrive. So we think not only about how we manage our crops, but how we manage the whole ecosystem and the economy that goes with it to increase the health and the wealth of our communities. In the Illinois Regenerative Agriculture Initiative, we work with farmers and with other stakeholders in the supply chain to think about those risks and work towards solutions that allow us to capitalize on the opportunities that always come with those risks.
To make climate smart commodity become a reality, we have to have the quantification tools to quantify the outcomes of the climate smart practice. If you are asking farmers to grow cover crops, and so farmer did this action, but can we quantify the outcome out of this cover crop practice? How much soil carbon the cover crop actually sequestrated over the time? Another example, if you are applying smarter fertilizer use application, then you have to quantify how much fertilizer you may saved in applying, but at the same time, you want to quantify the reduced N2O emission as well as the leaching. And all of that matters because all of these metrics will ultimately come to become so-called carbon intensity score at every individual field. And they vary from field to field because of the environment, because of the practice, because of the history of the field. At University of Illinois, we are really the pioneering scientists actually enable one of the most advanced technology to quantify this carbon intensity. We combine the use of satellite remote sensing, ground truth sensors, and models and supercomputers, glue them all together to comprehensively measure field-scale carbon intensity score. And we believe this type of the innovation really builds the foundation to enable climate-smart commodity.
Farmers depend on predictable weather and on natural resources in order to grow crops and livestock. And the pace of adaptation is just not keeping up with the pace that the climate is changing. So we're in a critical period, both to bring down emissions and to really accelerate efforts to build resilience to the impacts of climate change that are already happening.